Hey guys, I'm Jordan. I'm the production manager at Tempest 3D. I've been with Tempest since 2022, and I've also graduated from the Digital Fabrication course at Selkirk College. And I'm here with Jonathan. Do you want to introduce yourself, Jonathan?
Yeah, my name is Jonathan Guercio. I also graduated from the DFAB course in I guess it would have been 22, 21, the year before you.
Yeah.
I think so. We're lucky enough to be in the Selkirk Technology Access Center here with Tempest 3D, so going to be doing a little bit of an interview apparently with my products. Hopefully you guys like them, but I did work at Autodesk for about 6 months or so. I've always kind of been into 3D printing. I was part of the Nelson Tech Club back in the day when that was a thing. That was before this place even existed and that sort of stuff. So it was just kind of a natural progression to take this course and graduate and learn a whole bunch of skills, and it's been pretty fun for sure.
Awesome. Yeah, so I kind of wanted to focus on generative design because out of all the people I know, you've done the most of it.
Yeah.
So
for sure.
when you do your designs, did you do these knowing that you wanted to do generative, or was this kind of like generative experiments?
Well, the first one was the drone 100% experiment.
Yeah.
I was lucky enough to be working at the stack here, and one thing every single day is I wanted to learn something new. And I'm like, you know what, this generative design thing sounds very interesting. And I just got into FPV drones, and this particular FPV drone I was flying is really unique, where it has a very long flight time, but it doesn't perform very well. It's very slow, it's hard to maneuver, and et cetera and so forth, just because it's so heavy.
Mm-hmm.
So one of the things I have 3D printers. What can I do to make this drone better? Well, the obvious choice is I can't 3D print the electronics. I'm going to do the frame. That's kind of when I started diving down the unending rabbit hole of generative design for sure.
Mm-hmm.
And we'll talk about it more here in a second. But this is one of the more final versions, although as a designer, nothing's ever final.
Yeah. And like you talked about wanting to see some improvements. Do you think you saw some of those improvements when you went into the 3D printed versus your old version?
That's a super good question. The very first iteration, physical iteration, like
Mm-hmm.
digital iterations, I probably went through 40, I think. The first physical iteration, not at all.
Mm-hmm.
It was actually heavier, although it was built like a tank. Like, it was way stronger than it had to be, and that was me not quite understanding how generative worked and understanding what forces that the drone would see under normal flight conditions. And
Mm-hmm.
through experimenting and just thought experiments and like physically drawing and all this sort of stuff, I started whittling it down more and more and more and more and getting a better sense of what generative design is capable of. So this version that you see here, for sure,
Mm-hmm.
it is substantially lighter than the original one, which the original frame, if I remember correctly, is 24 grams. This one is 14.
Okay.
Which 10 grams doesn't sound like a whole lot, but when you're going from 24 to 14, the percentage is massive. And especially in a device, or in this case a drone that weighs 180 grams to begin with, like, that's a big amount of savings.
Mm-hmm.
And this is not including the shape optimization. So it's stiffer in the areas I need it to be stiffer. It's actually overall wider, so you actually get a little bit more control. It's a lot more stable while being lighter at the same time, which is really cool.
And have you noticed improvements in like flight control or flight time, or?
Flight time went down a little bit, and I think that's because there's physically more material in the way of the prop wash,
Mm-hmm.
which that's how it generates lift, but is way more stable.
Mm-hmm.
Like it flies like a Cadillac now, which is cool. It's not like this high strung or this like boat it used to be, which is nice. So
Yeah,
it's
and
good.
was this your first product into like aircraft design, or have you done any other aircrafts?
Nothing I would consider on this level for sure.
Yeah.
Like, everybody makes paper airplanes as a kid, but this
Mhm.
was kind of the first dive into, well, a quadcopter is just an X with props on it. How can I make that better?
Mhm.
Turns out there's a lot more to it than I myself expected.
Yeah. Are there a lot more iterations to come, or do you think this is kind of getting close to a final?
That's a good question. There's definitely a lot more iterations. One I've still been working on actually is kind of using the battery and the electronics as part of keeping the frame rigid.
Mm.
Because as it is, this is very, very rigid right now, but it doesn't necessarily have to be this rigid, because there's still a bottom cover that goes on that adds to the rigidity. the PCB adds to the rigidity, the battery adds to the rigidity. It's better to think of especially in terms of an aircraft, every part of the aircraft as a complete system instead of individual parts. So I definitely want to change some stuff. Make the frame a little bit thinner. The battery tabs I found were way too big, way too heavy for the small amount of amperage that was being needed. That was a big source of weight as well, was the metal. And other things like the fact that to screw the flight controller on this square, I can't access the screw from the top. It's blocked by one of the arms, so accessibility sort of things with that.
Yeah, you could do like a heat press insert or something and screw from the bottom, but another option is like if you, like I believe you can do like a no print zone when you're doing the design in Fusion. You can put like a don't put any material here.
Yeah, so I guess that goes into the next point of like, was generative design the right answer for this? I don't know, because I probably spent more time modeling places that would tell Fusion not to go into these zones when generating the frame than I would have just modeling a loose version of the frame and then putting it to topology optimization.
Yeah.
So like topology optimization and generative design kind of go hand in hand. One takes what you have, the basic design, and strips away what is not needed to whatever given loads that you tell the computer to go to. Where generative design says, here's my base geometry, they're not connected in any way. So in the case of the drone, I said the motors go here, it's a lot more complicated. The base frame goes here, stitch together the arms in such a way that it is strong in the ways that I've described the loads are.
Yeah.
Is that the right call? I don't know. Like in theory, I could have just made a flat plane, basically like this. Hey, now Fusion, and I use Fusion in this case, strip away what's not needed. I'd be willing to bet I probably would have come out with a very, very, very similar answer to this, with a lot less effort, probably.
Yep. Probably been a lot more two-dimensional. Like some of these wings like sweep up a lot. And
well, that's easy to do because with topology, I would have just had a big chunk.
Yeah, oh yeah.
And it would have stripped away anyways. So it's hard to say what would have been the right answer, but that's...
You think you would have had like that mid-frame brace that goes from the front to the mid, or would you have just had kind of the classic 4 arms coming out?
I think it would have ended up at the same thing.
Yeah.
I wanted that brace specifically for crashes. So I have in the programming, I have a very significant load in one of the load cases coming this way. So when you crash, you have that reinforcement for sure. And I'm sure, I'm assuming it's the same algorithm on the back end.
Yeah. And when you were doing it, did you do any research into your loads, or did you just kind of trial and error until you found something that was like the right stiffness and everything to fly?
Educated guesses, I would say. So you could call it research, I guess, but definitely educated guesses. Like, I know the drone weighs this much. If it's just hovering in place, you can divide the total weight of the load by the 4 motors, because that's where that load
and then multiply the safety factor or whatever you want to add to it.
Yeah, so you can do a safety factor if you wanted. I did a safety factor of 1 because my safety factor was in the physical loads I was giving it.
Yep.
So instead of just the weight, I said, this much. Or in the case of a crash, I said this many newtons, and this, just so we can account for a crash.
Yeah. Have you crashed it?
Oh yeah.
Okay. And it obviously it survived?
100%.
Nice.
Yeah, absolutely. For sure.
Cool. And what do you see for like future revisions? Like, I know you talked about some accessibility and stuff.
Probably quite a bit. So the accessibility is a big one. Like the ease of building should be key, because not only is it easier to build once, it's easier to repair when it breaks. Like this thing is very tough. I don't foresee it breaking easily, but you know what? It might get stepped on. It might get better to be repairable than not repairable, regardless. A few little stiffness things, like the back arms are not quite as stiff as I'd like. They're a little bit jelly, which it's not a big deal, but for the flight controller controls the motors given what it knows. So if the 4 motors are perfectly up and down, it can control it quite well. But if it suddenly gives thrust and the motor twists just a little bit, then suddenly that thrust vector's off and doesn't quite know what's going on. So having rigidity in terms of flight dynamics would be very nice, for sure. But then crash resistance, you want it a little bit flexible. There's a balance in there somewhere.
Yeah.
And then, like I said, the battery tabs are the big one. Like how heavy that is. I have to actually start learning about how many amps a certain tab can hold and size it appropriately and that sort of thing.
Yeah, I know this kind of started as like a passion project, but do you plan to kind of sell them or share the files or?
I don't think so. Not for something like this. This is what is called an FPV drone. So you fly it completely manually. It has zero autonomous capabilities. It's a glorified RC helicopter. It just happens to have 4 rotors. That's really the only difference. For better or for worse, that hobby is kind of going down, with being replaced by the flavor of drones that we think of, where you just launch it, control it with your phone, it does the thing and comes back. This frame is very optimized for FPG specifically. That's why, the rear motors are a little bit inset. The front is very beefed up for crashes. You're flying forward and that sort of thing.
Yeah. And when you do your generative designs, is your workflow much different from like a basic parametric design? Like when you start your design, do you know it's going to be generative and you kind of tailor it to that?
Totally. I wouldn't say backwards, but it's very opposite of what you might think. Instead of modeling what you want the drone to be, you model it where you don't want it to go. So like this is a headphone stand, for instance. I modeled basically everything around this. I did not model what was in here. So I knew the headphones, for instance, would hang about here. So I put a big object right here and said, hey, Fusion, don't generate any geometry in this area. So it's almost completely backwards in a way. And then again, that kind of brings up the question, well, what if I just started general with this like general shape and then told Fusion to do a topology optimization? Would that have been better or less effort, more say? I'm not sure. It's definitely worth experimenting.
Yeah, and it looks like this one's changed a few times too. Like it's much narrower in the back versus this MJF one.
Yeah, and full admittedly, that was just a style choice.
Okay.
I just wanted it to look cool. Although I did really reduce it from 6 feet down to, this one's attached to a base, but down to 4 feet, just to make it more compact and save a little bit of material for sure.
Yeah, because it looks plenty stable for like a set of headphones or.
Absolutely, yeah. And then I did want to decouple the arm from the base, so I could also go through the different bases and like, because I wasn't sure where the center of gravity would be, and each set of headphones could be different. If somebody wanted a different version for whatever, I could at least swap out the bases, or if you dropped and broke it, you could at least just unscrew the base screw on a new one instead of printing a whole version again.
Yeah. And when you're doing this, do you design knowing how you're going to manufacture at the end? Like you're going to 3D print it or sandcast it? Because like from what I've seen, it'd be very difficult to CNC mill these type of parts.
I wouldn't say impossible, but yeah,
but on 3-axis,
reasonable.
It's not worth it. Yeah.
The cool thing about generative design in Fusion is you can choose what kind of manufacturing process you're going to do. So like another project I was just playing with is just water jet. So they call it 2D axis milling, where so I told Fusion, I'm only 2D cutting this. Can you make me a generative design shape for that milling? And it did.
Oh, wow.
These ones are really cool because I just told it unlimited. You're not limited in any way, shape, or form. Which, when people think 3D printing, oh, totally, you can totally 3D print any shape you want. The real answer is not quite. For instance, this one was printed on your guys' MJF machine here in the stack. What's cool about MJF is it doesn't need supports. It is more or less unlimited as long as you can get the excess unbound or unfused material out of there. You can do all sorts of crazy shapes, and the machine doesn't care, which is awesome. Whereas this version that I printed for my mom, sorry, this is a little late because I had to do this interview. You should have seen the supports that was required on my normal, quote unquote, normal home 3D printer. The support itself it went from the print bed all the way up to the top here. It was probably the same amount of material as the arm itself.
And did you do like tree supports or just a standard? Because I feel like usually tree supports use less material, but
yeah, that's a very, it kind of gets into the nitty-gritty of FDM, but for this one, tree supports is very perfectly suited for this shape. Other times, believe it or not, standard supports can be better, but yeah, no, the optimized thin tree supports, but still the amount of material is just wasted for support, so it's pretty crazy. So a powder-based solution like the SLS machines or the MJF would be great, for sure.
Yeah. Yeah, I didn't know that Fusion had like two-dimensional generative design as well. Are you working on some other generative projects?
Not at this exact moment, but in the past for sure. So you can, there's a whole menu. You can say 2-axis, 3-axis, 5-axis, unlimited, 3D printing. So you can actually say, hey, I'm going to be 3D printing this. What direction's your nozzle? And you can say Z. And it'll optimize for that.
You could tell it, hey, I need like max of 45 degrees or something just to make it like, I want to print this without supports. Don't tip more than.
Exactly, that overhang. You can actually set what overhang is. So some printers are better at overhangs than others. You can fine tune that too. So it's actually a very, very powerful tool. It's very cool.
And what do you see for like any future for generative design?
As with any new technology, like when 3D printing first came out, it is another tool that creators or designers or engineers can use. Is it the right answer for everything? Of course not. Absolutely not. Is it a really, really powerful and really cool tool to do really cool things like lighting an airframe so it can it is heavily optimized for that exact specific workload you need it to do? Totally.
Yep.
Absolutely. It's really neat.
Yeah, I agree. Kind of tool in the toolbox, not the answer for everything.
Yeah, and I don't think there'll ever be a one answer for everything, but the more tools, the better, for sure.
Yeah. What wall thickness did you go with?
I think this is only 1.5.
Okay.
Like it's pretty thin, but you'd never know.
Yeah, because it feels like pretty strong. I would like, from the prints that I've done, I would have thought like 3 mil.
Totally. Yeah, that's just another thing about MJF, or I mean any powder base, but MJF is better at it because of MJF is more consistent on all axes versus something like SLS. It still has a little bit of Z weakness, which, anyways, for complicated reasons, MJF can be a little bit better. But yeah, it's hollow. Like there's no way you could have done that with any other kind of manufacturing, which is really neat.
Yeah, and you did end up, I believe that's the Cerakoted airframe.
Yeah,
right?
yeah. This one's Cerakoted, which is a ceramic coating that works really well with, I mean, the PA-12S, obviously. It's cool because this is going to be an outside drone, and it will be wet at some point, even though it's not supposed to be. It probably will be, or dirt, or ingress, or anything like that.
And that did, I believe that added like a measurable amount of weight.
It
like
did.
a gram or two.
About 2 grams.
2 grams.
I probably would have, like, for something where each gram is like very important, I think vapor smoothing would have been the better call because that still seals the surface and keeps water from getting in, because no matter how good the nylon is, it still likes water. It still likes absorbing water. The vapor smoothing can prevent that, which would be really cool.
Which the one after that one was vapor smooth, correct?
Yes, it sure was.
Yeah, and I mean, they look amazing, right? They come out with that glossy black. And
they do. I mean, is this one
that's
vapor smooth? Yeah, this one's not Cerakoted. This one's just vapor smooth. That's how hard it is to tell the difference between the Cerakote and the vapor smooth. Although the Cerakote's nice and hard. That's the key. Yeah. Yeah. If this was like on the ground sliding all the time, maybe Cerakote, but.
Yeah. For like abrasion, you want Cerakote, but I believe the vapor smoothing actually adds a bit of stiffness. I believe I've seen some reports on that.
Okay. I did not notice with my frame, but.
Yeah,
as with everything.
Like it's like in a technical data sheet, like it's measurable but maybe not noticeable kind of thing.
Totally. So. Yeah. Absolutely.
All right, well, I think that's all we have for today. Huge thanks to John for sitting down with us, showing us his projects. If you like content around additive manufacturing, product design, like and subscribe. We have a lot of exciting guests planned for future videos.